Hi, my name is Brian O'Gallagher and I'm delighted to introduce you to some of our postgraduate research opportunities in energy engineering at University College Cork. These research opportunities can be for 1 year, a research master's in energy engineering, or 4 years, a PhD in energy engineering. And our research is framed within the Marai Energy, Climate and Marine Research Centre that UCC hosts. Marai gives us a huge opportunity to do significant research at scale. We have partnership with 13 other institutes in Ireland and with about 80 industry partners. The Marai mission is captured here, and as you can see, there's a significant emphasis on energy, not just research but also innovation and commercialization, and a focus within our energy research on the energy transition. The summary mission statement on the bottom is that we seek to do excellent research with significant societal benefit within Marai. Our motivations centre around three of the grand challenges facing the world today: the energy transition, as mentioned, climate action, mitigation and adaptation, and the blue economy, the significant resources available to us in the oceans and the sustainable development of those resources. Our research is motivated by these three grand challenges, and it seeks to have significant impact in three different ways: supporting industry, informing policy and empowering society. And it's through these impacts that the real results of our research can be realised fully. So how do we do this? Well, some of our research is working with companies to support them to innovate, translating ideas into economic activity. And you can see here some examples. We've worked with a ocean energy company, a wave energy company from Cove, County Cork, who are developing a device that's being tested in the naval base in Hawaii at the moment. G-Kinetic are developing tidal energy devices, and we've supported them through lab testing and all the way through the technology readiness levels, and now it's at the stage where there's a demonstration device being tested off the coast of France. And we've also worked with a number of offshore wind energy companies to develop a strategy for the development of offshore wind energy in Ireland. And focusing on this latter one, this is a good example of where we've used energy research to advance the development of renewable electricity. And as you can pick up from these pictures, there's a significant engineering challenges associated with both the deployment and the operation and maintenance of offshore wind energy devices. And energy engineering is a core part of the competence required to deliver this. There are many other aspects of engineering associated with the development of offshore wind energy. Captured here, there's the data gathering, the wind resource, the wave resource, the geological information. How do we reduce costs associated with offshore renewable energy? Looking at the structures, looking at the electricity generation, the turbines themselves, the aerodynamics. There are many different dimensions to cost reduction. The opportunity to produce green hydrogen, to use the offshore renewable electricity to develop hydrogen, is another key part of our research in offshore wind energy. And of course, the environmental impacts. It's very important to understand the environmental impacts to ensure that offshore wind energy is developed in a sustainable way. Moving on to another topic area, energy efficiency. We have a Centre for Doctoral Training in Energy Resilience in the Built Environment. And you can see the focus of this in the text there. This is a partnership with two universities in the UK, University College London and Loughborough University. And as you can see from the picture, our cohort of PhD students are very happy to be doing this work. Another aspect of energy efficiency research in Marai focuses on the factories of the future. So how do we develop intelligent energy efficiency and supply in industry. And another strand is how do we retrofit our buildings? We have a significant amount of housing stock that requires improved energy performance to have a lower carbon footprint. So retrofitting of homes is another part of our research in this area. You can see here from the picture that this is a factory in Ringaskiddy where we've supported them to reduce their energy bill and also then to integrate wind energy. And this is part of how we use our energy engineering research to reduce the carbon footprint of companies. We're also collaborating with Irish distillers to develop low carbon whisky. So our energy engineers are helping companies to reduce their carbon footprint as well as to innovate. Another branch of our research is in the area of renewable gas. You saw in the previous slide the work with Irish distillers, and that comes from our biogas research team, who develop new approaches, new techniques for maximising the amount of renewable gas we can draw from, be it waste products or also energy crops. And then some of this gas is used for transportation. You can see Ireland's first biomethane bus in the bottom left. Another dimension of renewable gas is the production of hydrogen. I mentioned this in the context of offshore wind, and another key question associated with hydrogen is where will it be used? And so our research is focusing on the best use of this hydrogen. Will it be in heavy goods vehicles, in maritime transport, aviation? These are the types of research questions we explore in the area of renewable gas. We also have significant capacity in the area of energy systems modelling, and this is to inform policy decisions. Here you can see different possible ambitions for Ireland for emissions reduction. In this case, we're talking about carbon dioxide emissions associated with energy demand and supply. And you can see, depending on the level of ambition, the pathway for emissions reduction is linked to a certain level of temperature rise. And this is because of the connection, the interrelationship between carbon dioxide emissions on the one hand and temperature increase on the other. So we have many possible future pathways for our energy system, and this type of analysis helps governments to understand what the best strategy might be. So we've used this work to inform different policy decisions in the past. In 2013, we developed Ireland's first low-carbon energy roadmap, and this gave the politicians confidence to legislate for climate action. We also supported the government in developing an approach for how to negotiate with the European Union regarding mandatory targets for energy and climate. And this ultimately informed the final targets that Ireland received. We also did research to inform Ireland developing a white paper on energy. And this energy modelling looked at emissions reduction, but also things like energy security, how to address energy poverty, and other related topics. And that informed the white paper that was published towards the end of 2015. The analysis also informed Ireland's research strategy, in particular focusing on what specific challenges was Ireland's research infrastructure best suited to address. Following on from this work, we did further modelling in 2017, and this informed Ireland's first national mitigation plan, which was published in July of that year. And since then, we've been supporting the government to try and understand what it might require if we want to have further ambition in terms of emissions reduction. How do we increase Ireland's climate ambition? And that informed the Climate Action Plan in 2019. And also in 2020, government negotiation discussions about a further increase in Ireland's climate action ambition. And those discussions ultimately led to the formation of a government in 2020 with a very ambitious plan for emissions reduction. So I'm going to finish now with a video which shows some of our researchers talking about the research that they do.
What the SFI research centres have done, and in particular MRI has done, is when we work on our technologies, we're now working with a microbiologist, with an energy modeller, with an electrical engineer, and our problem is now addressed by 7 or 8 different disciplines looking at all the different complexity around the problem.
Collaboration is essential because nobody has all of the answers. We all at most have a small piece of the jigsaw. So by collaborating together, we can put our minds together, put our thoughts together, put our expertise, put our skill sets together. And the whole is greater than the sum of the parts, so we might solve the jigsaw.